Today I'll be covering the basic techniques of integration. Now this lesson is suitable for students who are taking the higher level math in the IB syllabus or the H2 math in the A level syllabus. Now, this is the three basic techniques I want to cover. These three techniques are very important because when questions on integration, more often than not, you need these techniques. Sometimes you need techniques that are more sophisticated than this, but when you come to the last part, all right, you may need these basic techniques. So without further ado, I will illustrate to you the proof of this first formula. Now let's try to differentiate this, the right hand side. Now this is actually a composite function. Let's differentiate this function. What do you get? You get n plus 1, and then this power n plus 1 you minus 1, so it becomes n. Alright, and then you differentiate the inside function. You got f prime of x. Now you integrate both sides. Integrate both sides with respect to x. So what do you get on the left? On the left, you simply get f of x to the power of n plus 1. Now over here, you have n plus 1. This is a constant. You can bring it out and you have fx to the power of n f prime x dx. Now you bring this down, all right? You have f of x to the power of n plus 1 over n plus 1. I bring this n plus 1 over to the other side, so I divide this on both sides. So you have fx and f prime of x dx. Now you're doing integration, so you need to, there's a plus c over here. How to remember this? Now, just make sure that the outside of this function is the differential of the derivative of the inside function. Then when you integrate this, all right, it's like your very basic simple integration. You integrate this plus 1 to it, and then you divide by the n plus 1. Now let's move on to the second one. Now to prove this is very simple. We differentiate this function here. D of e f of x dx. What do you get? You get f prime of x e f of x. Integrate both sides with respect to x. You have e to the power fx. And then this, you do the integration. Now because you are doing integration, so you need to have a plus c. Alright, we have proved the second formula. Let us look at the third formula. Now the third formula, let's differentiate this. D ln f of x dx. Now how to differentiate this? Now you differentiate f of x as f prime of x over f of x. So the integral of this will be ln f of x. Now you may be asking how come there's a mod. Now because this is a ln function, you cannot ln a negative answer. So that's why the mod is there. You are doing integration, so you need to have a constant. Because when you differentiate this, the constant is gone. So this is just an arbitrary constant. Now with this, I hope you understand how the proof comes about. Now let me just briefly tell you how do I remember this. Now you just remember this is the power, f of x is the power to e. Now you must make sure this part is the differential of f of x. Now for ln, for this, all right, you integrate this for the ln function, all right, you look at this. Now this one must be to the power of 1, all right, this one must be to the power of 1, or fx to the power of 1. Then the top is the derivative, the numerator is the derivative of the denominator. Then with that we can apply this formula. So you integrate this will be ln f of x. Now for that I have come to the end of the lesson on basic integration techniques. I will then use these techniques to do a number of sums in the next video. I hope you will continue to watch our video and learn something from there. Thank you very much and have a nice day.